Hi there, welcome to another video from Hegarty Maths. It's our 7th video on graph transformations in which we talk about all the transformations combined. Let's start by revising and thinking over the transformations we've gone through so far. The first one, if you had a function f of x, if you work out f of x add a, it shifts the graph upwards in the y direction by a units. If you think of a graph f of x, subtract a, it shifts the graph down by a units in the y direction, assuming a is positive of course. Let's think of another one we've learned. If you are trying to work out a multiplied by f of x, a is a number bigger than 1, it stretches the graph in the y direction by a factor of a. If you were to work out af of x and a was less than 1, it's between 0 and 1, it's a squash in the y direction by a factor of a. And the last ones of transformations in the y direction, if you were thinking of a graph negative f of x, what that does is it reflects the graph in the x-axis, or you can think of it as multiplying the y numbers by negative 1. Now let's think of the transformations that happened in the x direction. The first and easiest were the following. If you're considering f of x add a all in brackets, it actually shifts the graph to the left by a units. On the other hand, if you are trying to draw the graph f of x subtract a, it moves the graph or translates the graph a units to the right. Next one we've learnt about, if you're trying to work out f of ax, where you're multiplying the x number by a. If a is bigger than 1, it squashes the graph by a factor of a. If a is between 0 and 1, it stretches the graph out by a factor of a. And the last one we've talked about is f of negative x. Remember what we said there? We said that's just a reflection in the y-axis, or you can think of it as multiplying all the x numbers by negative 1. So in this case in particular, this turning point here would be at negative 3, positive 1. And maybe as a little summary to help you, anything inside the brackets affects the x numbers, and it kind of does the opposite to what you may expect. Anything outside the brackets affects the y numbers or the y direction, and it kind of does what you would expect. So we can use that as a little guidance to us when we're doing combined transformations. Let's get straight into a question. Pause the video, have a read through. So we have a graph of f of x given. We are told one of the turning points, which is 3 across, 2 up, and we're asked to state the coordinates of the turning points under this transformation here. Now, two transformations are going on here, one inside the bracket and one outside the bracket. Okay, so we are subtracting 2 inside the bracket. Remember, inside the bracket affects x, kind of does the opposite to what you think. So we're going to move the whole graph 2 units to the right actually. And adding 5 is outside the brackets, so it's in the y direction, and it kind of does what you think, which is move the graph up by 5 units. So it's pretty good here. All we've got to think to ourselves is we need to add 2 to the x number, we need to add 5 to the y number, so the turning point therefore would be at 5, 7. Okay, adding 2 here, adding 5, and we're done. What about in this case? Well, there's two things going on here. We're adding 5 inside the brackets. Remember, when it's inside the brackets, it's to do with the x's, it's in the x direction, it kind of does the opposite to what you think. We are going to move the whole graph backwards by 5 units. Now multiplying by 3, what's that about? Well, that's outside the brackets, so it affects the y numbers, and it's a stretch by what you kind of think by a factor of 3. So it's going to stretch the whole graph out, multiply the y numbers by 3. So what do we do here? Well, looking at 3, 2 here, we need to move the x number to the left by 5. We need to subtract 5. 3 subtract 5 is negative 2. The y number we need to multiply by 3. 2 multiplied by 3 is 6. Okay? Now, the last one here, we have got ourselves two things going on as before. We are adding 4 inside the bracket. Remember, that's to do with the x direction. It kind of does the opposite to what you think. It's going to move the graph to the left by 4 units, and we're multiplying by negative 1. That's affecting the y numbers, and what it does with in the y direction, it multiplies all of them by negative 1, which is kind of like a reflection in the x-axis. Let's think what happens therefore to our coordinates. The x numbers move to the left by 4, so we're going to do 3 subtract 4, which is -1. The y number is going to be multiplied by -1. 2 multiplied by -1 is -2. And there you go, we have done some combined transformations. Let's have a go at one more. Pause the video, have a go at this yourself. This time we're given a curve and we're given its turning point is 5 across 3 down, and we're asked to state the coordinates of the turning points under these transformations. Do what we did before, break down the transformations into its components. We're adding 2 inside the brackets, so therefore that's in the x direction, going the opposite to what we think, so we're going to move everything to the left by 2. We are subtracting 3 in the y direction, so we're doing kind of what you think, we're moving downwards by 3 units. So what we're going to do to this point here, we're going to subtract 2 off the x number and get 3. We're going to subtract 3 off the y number and get -6. What about this one? Well, we are multiplying by 3 inside the brackets. Remember, that's affecting the x numbers, but when it's inside the brackets it does the opposite to what you think. So because you're multiplying by 3, you think you multiply all the x numbers by 3 or stretch them out, you actually squash the x numbers by 3. You divide all the x numbers by 3. And the add 5 outside the brackets, well, that's to the y numbers. That's kind of doing what we expect. It's shifting the whole graph up by 5 units. So let's think what we do. We're going to divide the x number by 3. The x number is currently 5. We're just going to divide it by 3 and leave the answer as 5/3. We're going to add 5 to the y number, and -3 add 5 is +2, and there's our turning point. The last one here, the two things we've got going on, we are multiplying by -1 inside the bracket. Okay, so that's going to be, remember, a reflection in the y-axis, and we are adding 4 outside the bracket. So what we can think of this as multiplying the x numbers by -1, and we can think of this as moving the whole graph up by 4 units. So if we reflect this in the y-axis or multiply it by -1, we get -5 there, and if we move this point up by 4 units, we get +1, and we're done. And that's pretty much it for this video. If you do want to stay tuned for a minute or two, I'm going to just link this back to completing the square and how graph transformations actually link to completing the square for quadratics. So this is not essential, but it's interesting. I want you to pause the video and state the turning points of the following graphs that are in completed the square form. Thinking back to your completed the square form, we know that any graph in the form x add p all squared add q, if we have a graph in that form, its turning point is always at -p positive q. So the turning point here would be at -2, 9, and the turning point here would be at -4, which is +4, and -5, like that. And we learnt that when we were in the quadratics drawing graph sections. Completed the square allowed us to quickly identify the turning points. Now I just want to take a second to link this to graph transformations, and I'm going to do it in an example. Here we go. Suppose I showed you the function f of x is equal to x squared, and on the same diagram I asked you to sketch f of x subtract 2 add 5. By graph transformations, we know that take away 2 inside the brackets moves the whole graph to the right by 2 units. So in particular, let's focus on this point here, 0, 0. That's going to move to the right by 2 units. And the add 5 here is going to move the whole graph up by 5 units, up to somewhere like here. And that's going to give us the coordinate there, 2, 5 for this point, and we would have something that looks like this. And by graph transformations, we would have moved the graph 2 units to the right and 5 units up. Now, suppose on the other hand, I gave you a different graph, y equals x squared subtract 4x add 9, and I said by completing the square sketch the graph. Well, if you were to complete the square here, you would have x subtract 2 all squared, and that would give you x squared subtract 4x add 4, take off that 4 and add back that 9, you would get y is equal to x, take away 2 all squared add 5. Now because that's in completed the square form, you know its turning point is 2 across 5 up. This is looking familiar to what we did on the left hand side here, and you would know that the graph is something like that, just like we did over here. What's the link? Well, the link is that completing the square here is really just a way of us transforming the y equals x squared graph. The reason completing the square works is it's basically the y equals x squared graph transformed, in this case by 2 units to the right, 5 units up. Hence, what was the turning point of 0, 0 in the case y equals x squared is now a turning point at 2, 5 in this particular case here. So that's just a bit of a link there to why completing the square works, and it's linked to graph transformations. That's it for this particular video. Thanks for watching.